This is homework for Wednesday, March 9th, page 53 in your Thinking with Math Models book, number 38. So it gave you 4 tables, and it's asking you to use the equation given to fill in the table, and then tell whether it's linear or not. So how I use the equation is I put in all of my x values given in the table, and I plug those in for x, and I solve. So if I plug -5 in for x, it looks like this. -3 times -5 minus 8. And I just solve that for y, and I get y equals 7. So the value for y is 7. And then I plug in -2. Y equals -3, -2 minus 8. So that means -3 times -2 minus 8 is -2. I put that in, so I continue to do that. So -3 times 1 is -3, and then minus 8 is -11. And then -3 times +4 is -12, minus 8 is -20. So after I've filled in the table, let me get rid of my work here. Nope. I can now figure out if it's linear or not. So by doing that, I'm going to put in my carets. Let's change the color. So from -5 to -2 is going up 3. -2 to 1 is up 3, up 3. 7 to -2 is going down 9. -2 to -11 is going down 9 and down 9. So already I can tell that since all of the x values are the same and the y values are the same, when I divide them, I'm going to get the same thing. -9 divided by 3 equals -3, which gives me a constant rate. So this is the constant rate, which means it is linear because it has constant rate of -3. Okay, now B, again I have to use the equation to fill in the values for y. So I'm going to plug all my x numbers into the x spot. So for instance, the first one would be y equals 4 times the quantity -3 minus 7 plus 6. And so I always do, because PEMDAS, I do parentheses first. Y equals, so -3 minus 7 is -10 plus 6. 4 times -10 is -40 plus 6. Y equals -34. Okay, you could just be doing this on your calculator. You don't have to write it out like I have. So I'm going to put that value in here. And then for 0, this one I could kind of do in my head. 0 minus 7 is -7. 4 times -7 would be -28. And then plus 6 gives me -22. Okay, then, and for 3 minus 7 gives me -4. 4 times -4 is 16. Plus 6 is -10. And then when I plug 6 in for x, I get 2. Okay, so now I can see if it's linear or not by putting in carets. From -3 to 0, is going up 3, up 3, up 3. And then from here it's going up 12, up 12, up 12. So So I can do change in y divided by change in x gives me 4, which would give me the constant rate. So now I want to look at the equation they actually gave us, because you should be able to tell from the equation if this is linear. So yes, it has parentheses in it, but if I were to distribute out the 4, so 4 times x and then 4 times negative 7, I would get y equals 4x minus 28 plus 6. And then I could combine my like terms, which is negative 28 and positive 6, and I end up with y equals 4x minus 22. And now looking at the table, I found a slope of 4, slope of 4. Y-intercept shows negative 22, y-intercept negative 22. So yes, the table helps me realize if it's linear, but the equation also tells me if it's linear. If I have a coefficient in front of the x, and if I have a y-intercept. So this one is linear, has constant rate. And then looking back at A, the equation they gave us is already in linear slope form. Negative 3x is my slope, my coefficient that I found from my table, and the y-intercept would be negative 8. Okay, C looks kind of confusing, but we just put our x value in for both x's. So the first one would be, darn it, y equals negative 3, because I'm substituting that first x, and then times 3 times negative 3 plus 2. So I've got y equals, let's see, 3 times negative 3 is negative 9 plus 2. And then I have y equals negative 3, negative 9 plus 2 is negative 7. And then negative 3 times negative 7 would be 21. So that's my first value. So next one, the 0 goes in the x spot, so I have 0 times 3 times 0 plus 2. So if the 0 is here first, 3 times 0 is 0, plus 2 is 2, and 2 times 0 is 0. And then again, if I plug 3 in, 3 times 3 is 9, plus 2 is 11, times 3 is 33. And then plug 6 in. 3 times 6 is 18, plus 2 is 20, and then times that by 6, and I get 120. Okay, so now let's look at the carets. This is adding 3 each time. And then from 21 to 0, we're going down 21. From 0 to 33, we're adding 33. And from 33 to 120, we're adding 87. So I can already tell there is not a constant rate in the situation, because negative 21 divided by 3 is negative 7. Oh, sorry. It should be, yes, negative 7. And then 33 divided by 3 is 11. And then 87 divided by 3 is 29. So I get different answers each time. Now let's look at the equation though. If I were to factor that out, x times 3x plus 2, and I did x times 3x, I would get 3x squared, and then x times 2 would give me 2x. So this is not a linear equation. So not linear. Okay, last one, D. Right away you should be able to recognize whether the equation is linear or not. Is there a coefficient? Yes, negative 3, because that's in front of the x. So let's fill in our table. I plug all my x numbers in for x. Negative 3 times negative 3 is 9. 4 minus 9 is 13. Sorry, that would be 4 plus 9 is 13. And then negative 3 times 0 is 0. 4 minus 0 is 4. Negative 3 times 3 is 9. 4 minus 9 is negative 5. Negative 3 times 10 is negative 30. 4 minus 30 is negative 26. Okay, and do my carets. This is going up by 3 each time. But then right here it's going up by 7. And then I have going down 9, going down 9, going down negative 21. So you might think it's not linear because I have different numbers here, but we still have to do the dividing. Negative 9 divided by 3 is negative 3. Negative 9 divided by 3 is negative 3. And then negative 21 divided by 7 is negative 3. So this is my constant rate, which in the equation is right here, the constant rate, the coefficient. And then the slope in the table is 4, and here's the slope in the equation. So this is linear. Okay, that's the end of homework, and your word for today is tenuous. I hope you're studying for your test tomorrow.